Hello everyone, my name is Ashvik Goyal, and today I'll be teaching two important concepts from Unit 1, Characteristics of Functions, in Integrated Math 2. The main purpose of Unit 1 is to understand different types of functions and how they behave. Throughout this unit, we learned about absolute value functions, direct and inverse variation, inverse functions, properties of exponents, radical and rational exponents, and exponential functions. These concepts are important because functions describe relationships between variables. They help us solve mathematical problems, model real life situations, and prepare us for more advanced math topics that build on these ideas later in life. Today, I'll explain two concepts from this unit. First, I'll solve an absolute value equation, then I'll show how to find and verify the inverse of a function. For my first example, I'll solve the equation the absolute value of 2x plus 5 equals 15. The first step is to isolate the absolute value, which means to keep it on one side of the equal sign. As you can see in this equation, it's already isolated, so I can move to the next step. Because absolute value represents the distance from zero, the expression inside the absolute value can have a positive value or a negative value. This means that I have to have two separate equations for each one. The first equation is 2x plus 5 equals 15. The first step I do is subtract 5 from both sides to isolate the variables term on the left side. Now I have 2x equals 10. Next, I can divide both sides by 2 to get rid of the coefficient and solve for x. So my first solution is x equals 5. Now I'll solve the second equation. 2x plus 5 equals negative 15. Again, I can subtract 5 from both sides. Now I have 2x equals negative 20. And then I can divide both sides by 2. So my second solution is x equals to negative 10. Now we can check both answers by substituting them back into the equation. When I substitute 5, I get the absolute value of 15, which also equals 15. When I substitute negative 10, I get the absolute value of negative 15, which is also 15. Since both solutions make the original equation true, my final answer is x equals 5 or x equals negative 10. Now we'll find the inverse of a function. The function is f of x equals to 5x minus 7. So the first thing we do is rewrite this as y equals to 5x minus 7. Next, we should switch the x and y variables. We do this because an inverse function reverses the inputs and outputs of the original function. Now the equation becomes x equals to 5y minus 7. Now we'll solve for y. First, I add 7 to both sides to isolate the term that contains y. Now we have x plus 7 equals to 5y. Next, I divide both sides by 5 so that y is by itself. So this gives us y equals to x plus 7 divided by 5. Finally, I can replace y with g of x because this is the inverse function. So the final inverse function becomes g of x equals to x plus 7 divided by 5. Now we can verify that these functions are the correct inverse. First, we substitute g of x into f of x. After simplifying, the result is x. Next, I substitute f of x into g of x. After simplifying again, the result is also x. Since both compositions equal x, I have proven that these two functions are inverse functions. Hello, today I explained two important concepts from Unit 1, solving an absolute value equation and finding the inverse of a function. For the absolute value equation, I split the equation into two, solved each one, and checked both solutions. For the inverse function, I switched the variables, solved for the new output, and verified that both functions were inverses by showing that each composition simplified to x. These concepts help us understand how different functions behave and increase our foundation for future algebra and different problems we could encounter. Thank you for watching.